right, so hello everybody. I hope you're enjoying your time in this beautiful city. Thank you for organization, for invitation and everything. Today we are going to present to you our project, Atomic Threat Coverage, which represents technical implementation and operationalization of threat-centric methodology and MITRE ATT&CK framework specifically. At the same time, we will present to you the reasons which stands behind the decision to develop this project, and expected and a few unexpected benefits which we had when we started processing all information automatically. Also, everything we're going to present to you today is free and open source, available on GitHub, and ready to be implemented in your environment. All right, my name is Danil. I'm working as a threat detection team lead in ATT&CK in Czech Republic. Today we will perform together with Mateusz Wydra. He is SOC incident responder in ATT&CK in Krakow, in Poland. Also we have two members who unfortunately couldn't participate today. Michael Aksonov, he is SOC automation team lead in Moscow, in Bizon. And Jakub Weinzettel, he is threat detection specialist in ATT&CK in Krakow in Poland as well. At the same time, we all Krakow 26 Congress meetings members. These are our home meetups, like local meetups, I would say. We used to present first proof of concepts or interesting ideas, updates there first. So if you guys will be in Krakow, come over, say hi. These meetings takes place each first Friday of the month. All right, let me provide you some historical background. In 2014, when I moved from networking security to general computer security and started working with offensive, defensive stuff, I had only one question, and also started working with CM systems specifically. I had only one question: where all of these people get correlation rules? And I couldn't find the answer. The thing is that at that time, basically, if you're looking for like correlation rules, detection rules, methodology, anything, you can only find like information about brute forcing. Everybody was like, you know, buy our SIEM system for a couple of $millions and you will be able to detect brute force. All right, maybe something else. Basically, I started also doing some hacking stuff, offensive, and I was able to intrude into system, move laterally, dump credentials and everything, but I couldn't find any information about detection. Like literally, you know, empty field, silence. No articles, no methodology, nothing. And for me, it was clear that to detect something or to defend the system from something, you need to understand this something, right? Like how the adversaries operates, how it looks like, what kind of tools they use, and what is their motivation. And I couldn't find the answer for these questions, like why nobody is doing that, why it's so obvious but not so popular. And I was digging into the topic, like looking for something which would reflect my own understanding of this area, and I found one. It's called Intelligence-Driven Defense, developed by Lockheed Martin Corporation in 2012. And the main idea behind it is you're supposed to know your enemy. It is basic for military, but not so popular. At least it wasn't that popular that time, basically just 5 years ago. So I grabbed it, started digging into what interesting is there, what can I use. And, you know, after just 1 year in 2015, MITRE released their framework called MITRE ATT&CK. How many of you guys use MITRE ATT&CK framework in your daily job? Can you please raise your hand? Great, that's just awesome. Thank you. So for those who are not using or not familiar, I will provide just simple description. It's just basically adversary model. Description of steps, techniques, procedures, and tools adversaries use during the intrusion and post-exploitation activities in our environment. Probably most of you familiar with concept of cyber kill chain, also known as cyber attack life cycle in MITRE paradigm, basically what they did, they just split it into two pieces, pre-attack and enterprise attack, which is about delivery exploitation and all post-exploitation activities which adversaries do. And basically, that's how it looks like. It is a table. There are 12 columns which represents tactics. Tactic is a tactical objective of an adversary during the intrusion. And there are more than 200 cells which represents techniques, which are like exact way how to achieve this tactical objective. For example, exfiltration over alternative protocol, it is a technique. At the same time, it is a way how to achieve tactical goal, which is exfiltration. There is a simple description of what is it about, mitigation detection strategies, example of use in the wild, and some references. So basically, each technique has such description. So, and with all of this stuff, like all of the mindset, we of course decided to start implementing it. And we faced a few problems during the operationalization. First of all, description for MITRE itself is too high level. It's not actionable, which means that you cannot just pick up these advices about detections, mitigations, and go and implement it in your environment. To actually implement it, you need to be more specific for yourself, like understand what you are doing and why. At the same time, it's always a teamwork, so you need to explain your team members, other departments, leadership, what you are doing, why you are doing this, and everything else. So it needs to be like detailed to be operationalized. Another thing is, which is following from the first topic, is that MITRE attack by itself doesn't provide you with the ability to explain what exactly do you need, and doesn't provide you with the arguments, like proofs, why exactly you need this one. The good example of such thing is sysmon log source. When you are saying your CM team, like, hey guys, I want to have sysmon in our detection engine, because I heard that you can detect lots of things with that. And they're asking you, all right, how many data you will, like, what will be increase, like in our EPS? What exactly you need to install there? And why don't you like the default, like, you know, Windows event log, like application security and system channels? And it is a relatively simple question, but to answer it and to be understood by everybody, you have to do like huge research, like what exactly you can detect with sysmon, why it is better than Windows event log, how many data like you will have after that, and what can you detect, like many things. So each time somebody is asking you to prove something, to explain yourself, you have to do lots of things to provide these proofs and compelling arguments. And last thing, well, basically there are lots of things, but these are main for us. Reporting to leadership. Basically, when you are starting the implementation, leadership want to know how you're progressing, what is the roadmap, what is the current status, and where you will be like in 2 months for each and every customer, because we are MSS, we're supposed to do reporting per customer. So, and it is also something which is supposed to be simple, but anytime you're preparing the report, you have to collect lots of data from multiple departments, compile it together, provide in an understandable way for management, which is also kind of challenging. And that's why in 2016, summer 2016, we decided to create our own tool or our own framework based on MITRE, and to basically operationalize this. And it's called not a MITRE team. It's called use case framework. Yeah. So you may have heard about it in some conferences in Poland or in Luxembourg in 2017 or 18. But if you haven't, don't worry. Today we will present you the same benefits and something new and more actual. So basically, what was it? It was a confluence knowledge base with the listed structure. We were using MITRE ATT&CK as a separate use case, and we were mapping multiple entities to this use case, like alerts, related data needed for which required for this alerting, and related logging policy. And this way we were expressing ourselves to CM team. Also, we were mapping their response actions, response playbooks, and many other things. So Mateusz will tell you more about it just in a few minutes. So basically, we solved the problems I've listed using this tool, but we got another set of problems. Good example of it is the unit test. Unit test is an entity which allow us to trigger some specific detection rule. And we were putting all of this stuff manually to Confluence page. So basically, just to execute it, you need to go there, copy paste it, and to victim machine to trigger something. And everything was filled manually and maintained manually. Another example is detection rule. We were using our own language to describe detection logic for CM team. We call it high-level detection logic. Well, basically everything is simple. At the same time, we were supporting Kibana queries, Splunk queries, and CM team were doing their own stuff, and everything was done manually. So just imagine if you want to add their new service name, for example. We have to update this logic, we have to update Kibana query, we have to update other things, which require quite a lot of time. That's the simple, let's say, overview of the stuff we had. This one is the use case. There you can see like biggest square is the use case with a lot of links. There are data needed, logging policies, software, and other stuff. And everything was tightly connected. So just imagine, for example, when we were creating data needed entity, there were no such thing. We were putting this data into logging policy. And we decided one day, like, well, it makes sense to separate these things. And we started working on a new entity, and we had to rebuild basically everything. Change all the links, add new links, create new articles for each data needed, which took like 2-3 weeks for 2 specialists. And that's really a lot. And we're not counting the general maintenance. Another problem just following from that is that we were deprecating some stuff, but still there are too many places where you should update it. We just, were missing some places, and that's why in some lists we were seeing these deprecated alerts or deprecated other kind of entities. So last fall we reached some horrible number. If you think it is small, how about that? So, really guys, it's when you're maintaining such amount of analytics manually in web-based engine, it became a madness. That's why last fall we decided to change. And we were inspired by 2 projects. First is Elastic Command Schema. We were contributing to it at that time. And we were really inspired by the way how they handle their stuff. So you basically update one configuration file or add something there, edit it, and execute make command. And after that, it regenerates all the documentation, all the CSV files, all the index templates, basically everything for you in the background, like automatically, which is just awesome. Another project is Sigma. We were using Sigma in the beginning in the first versions of use case framework, but then we decided to change to our own logic due to some internal reasons. But last fall, we saw huge community support for this project. At the same time, they've started mapping their rules to MITRE ATT&CK techniques, and that's why we decided to try to use them again. And what's happened then? Beautiful integrations, automated workflows, big discoveries, and also fun and profit for us and for community. And Mateusz will tell you more about it.
Thank you, Danil. Hello. We've set a few requirements for ourselves. First of all, we wanted to work with plain text files. because they are easier to manage. We could use version control systems like Git and do some bulk changes inside of those. We decided to not do any kind of maintenance in web-based editors because that amount of work which we did in Confluence was just overwhelming, and we decided to not do that anymore. We wanted to minimal manual job to be able to focus on more meaningful work like developing new rules or tests, and we wanted to automate everything which was able to be automated. So following that requirements, first of all, we wanted something to work for us as trigger entities, and we decided to use atomic red team for that. And if you are not familiar with this project, it uses atomics, which are tests mapped to MITRE's techniques and might be used for testing detection capabilities and mitigation systems which are implemented. So those atomics are stored in YAML files, and they contain actions which might be executed by adversaries or red team. And what's really cool about this project is that it also comes with execution frameworks, which basically makes all of those tests actionable. So you can prepare a list of tests which you would like to execute and quickly execute all of them in your test environment using those frameworks. So once we had something to test, we needed to detect such activities. And for that, we decided to use the Sigma project. If you are not familiar with it, it is the generic signature format for CM systems. And the real power of it comes from its converter, which is able to translate rules which are stored in Sigma format into queries for multiple CM systems like Splunk, Elasticsearch, Kibana, Greylock, ArcSight. The list of supported systems is quite huge, so that's only some examples. And that's how sample rule written in Sigma format looks like. As you can see, inside the tags, we have mappings to MITRE's techniques and tactics. There are some references and the conditions which are necessarily to met for the rule to trigger on some specific event. So to make those rules work correctly, we have to collect proper data. And to keep track of it, of what we have to collect, we've created data needed entities. So here we have the raw log sample, which you may want to pass to CM team or data engineers to show them what they should expect. The list of the fields, redundant ones here are used for the analytic purposes. Also the provider of that log, some references, and what's most important, it also lists the logging policies which are needed to be implemented to collect some specific data. And that's how sample logging policy entity looks like. So as I said, they describe what have to be configured to collect some data, and at the same time they provide exact steps which have to be followed to collect to implement those policies. And recently we also created new entity which is customer, and this one allows you to track which data you are collecting, which logging policy and which detection rules are implemented. And it's not like this is useful only for the service providers, because for internal security teams, the customer might be another department, remote office, or even some specific assets like some server or group of the hosts. Going further, we've introduced enrichment entities, and those entities describes how to enrich events with additional information. So here we have the list of requirements, a list of events which might be enriched, and description of the goal of some specific enrichment. For example, this might be introduction of new fields, renaming, or translation of some of the existing ones. And it also contains the configuration which is needed to achieve such enrichment. Another thing are response actions, and we've created those for incident response teams. So they contain the workflows associated with specific incident response phases. And we are using them to construct the response playbooks. And response playbooks are used as incident response plan for some specific threat, and they are using response actions as building blocks. And since those were written in very granular way, it gives ability to use same action inside multiple playbooks. So if you will update the response action, all of the playbooks which uses that action will be updated as well. Quite new stuff are visualizations. So here we are aiming for ability of creation visualization independently from the systems. Currently we are supporting only Kibana, but our next goal is to support the Splunk as well, and in future maybe other systems. So as you can see, it's just the description of what have to be visualized. And we are using them to create the dashboards. So it allows you to create dashboard by just listing the names of visualization in which you are interested. And they're supposed to be shareable and easy to maintain. So a few words what's going under the hood. We separated data, logic, and presentation layers from each other. All of our entities are stored in that YAML files, which I just showed to you. So it's easy to do some changes inside of them or create new stuff. For example, if you have some custom logging for application, it shouldn't be a problem to add them. We wrote most of the code in Python, and we wrote few modules to present that data in different formats and calculate some mappings between them. And what's also worth to mention that we are using the Jinja templates for human readable wikis. So it's kind of easy to adjust how you want to present it. And since it's Jinja, it also allows you to create new export formats. So currently we are supporting only Markdown and the Confluence, but it shouldn't be a problem to export that data to other wiki systems like MediaWiki. And small demo time. So I would like to show you step-by-step kind of detailed tutorial how to implement atomic threat coverage inside your environment. So it starts from execution of make utility. And basically that's all. That's all you have to do. So what just happened? All of the submodules which are connected were updated. In this case, it was the public version of Sigma project and Atomic Red, but this part is configurable. So if you have your own private forks of that projects, you can configure ATC to use those. All of the entities were exported to Markdown, to the Confluence, and additional files with analytics were created. And Danil will show you right now how it looks like after that export and what you can do with the files which were exported. Thank you.
Thank you, Mateusz. All right, say. Come here. So guys, I just want to ask you to follow this QR code, or better, if you have a laptop, better use this short link to open our demonstration. It's available in the public, but for mobile phone it looks horrible, so better to use laptop. Basically, I'm gonna show you how it looks like in Confluence, and again, just to refresh what Mateusz said, everything which we're gonna show you right now based on open source Sigma detection rules and triggers from Atomic Red Sim, and some, again, open source analytics from our side, like data needed, logging policies, and related things like response actions. All right, I hope you've managed to do it. So basically that's how Confluence looks like. As you can see, the structure similar to use case framework, but a bit different. So it was created automatically, just please keep it in mind. If you will open detection rule, you will see this rendered table with all the mappings, clickable links to attack tactic, techniques, automatically calculated data needed entities and links to them. Linked to trigger, which is atomic red sim test. And also here you can find the original Sigma rule, which was used to render this page. Also, a few automatically generated queries. And this list of queries could be adjusted by your needs. For example, if you need Splunk, just add Splunk to configuration and you will see that automatically generated query for it. So if we will click to data needed, we will go to this article. Here you can see a simple description of what is it. And again, very important thing is logging policies, because data needed just not exist by itself. You have to configure something to have this data in place. So basically how it works, you just provide CM team link to the article or list of links to articles, and they just click into link, so I need this data. To have this data, I need this logging policy. Everything is kind of clear, transparent, and detailed enough. All right. Also, you see here definition of type, provider, channel, and list of fields for analytics, which I will show you in a minute. At the same time, there is a raw log sample, which is required for CM team to explain them what they should expect on the receiver side. All right, returning back to detection rule, there is a link to trigger, which is basically original atomic red sim test. And here we have original article created by, automatically generated by Atomic Red Sim project itself. They have description from MITRE, list of atomic tests, and the tests themselves. So basically, everything is here, presented in a human-readable way. Also, there are multiple entities, but I'm not going to show you all of them. Basically, you have a link. You can go there yourself, and we are limited by time, so I will show you only one more, which is response Playbook. And again, here you can see the same style of page with links to MITRE ATT&CK framework, all the mappings from YAML file. And if you remember, in YAML file, you only had this links to response actions, which are constructed following the 6 steps, instant response lifecycle steps. And here we have description of workflow, again from the same YAML file, but at the same time, in the body of this article, you have all the response actions rendered automatically. So basically, in case of phishing attack, you just provide this playbook to SOC analysts or incident responders, they're following their stuff. But the main power of this entity is ability to export it to the Hive platform. You may have heard about it, but if you haven't, the Hive is the, I would say, the best, or at least most popular free open source instant response platform. So atomic threat coverage translate this YAML file not only to Confluence Markdown, it also can create a case template for the Hive. Basically, what we're gonna do, we will go to case management or case templates, I don't remember. Yeah, click import, going to atomic threat coverage folder, picking up automatically generated profile or case template. And here we see that this case template was created, and we can create the case out of it. So basically clicking new case, the case template, putting there some random name. As you can see, all the mappings already there. So that's how it looks like. Description from YAML file, all the metrics from, again, from YAML file, and the response actions mapped as tasks for this case template. And if you will open it, you will see original description from response actions here in this task. So basically you can assign this task to some of instant responders, or like do it yourself, click start, and like, you know, just follow your procedure. Alrighty. Next one, and again QR code. And again the same, I just would like to ask you to not use your phones for that. Better use your laptops if you have such opportunity, because in the mobile version it looks like really bad. So I will show you the analytics dashboard based on open source Sigma rules, and again with some of our, let's say, automatically calculated mappings. Whoop. All right, so here you see a description. It says that there are 211 detection rules or Sigma rules from open source project. We updated it yesterday, so it is actual. We provided some extra calculation for data needed logging policy, and there are test customer entities just to demonstrate what customer entity was built for. So first row is distribution of detection rules per MITRE ATT&CK tactic. Well, basically everything is simple here. On this diagram, we see that almost like 95% of our rules were not implemented anywhere. This way we can track how many detection rules we have in some specific customer environment implemented. Next thing is distribution of data providers per detection rules. Here you can see that most of open source Sigma rules are based on two providers, Sysmon and Windows Event Log security auditing provider. Next thing is that we can highlight that Sysmon is not just provide to us majority of the detection rules, it's also provide us most of critical rules. So this way, you know, we can easily explain why we need some specific data source to leadership or other teams, to basically to anybody. Next thing is distribution of development status per detection rule. Here you can see that almost 80% of open source Sigma rules have experimental status, which means that you cannot just implement them in your environment. You need some extra testing on production data or just in the test lab. It depends on your requirements. And only like 3% stable, kinda. So not defined for the rest. Which is also can be used, like if you are saying, I need some extra resources for my threat detection lab, you can show this diagram, you know, kinda supporting. Also a few tops, like as you can see, most detection rules were developed by Florian Roth, one of the authors for Sigma. And another one is says that majority of like 90% of all rules were built upon two event IDs, Sysmon Event ID 1 and Windows Event ID 4688. So basically both are about process execution with command line. Alrighty. Yeah, and the last demonstration for today. Expert to Attack Navigator. If you don't familiar with that, this is a tool for exploration analysis, like mostly for gap analysis. It was created by MITRE. And before ATC, we were developing Attack Navigator profiles per customer manually. You know, it's a handy thing to show to your manager or to customer, like how we're progressing, what is the current coverage, which is kind of questionable, but whatever. So what we did, we just generate this profile per customer and for all existing analytics. So basically, everything is already generated. We just picking it up. Yeah, you have to click like add new layer or new tab, open existing layer, open analytics, generated, back navigator, and choose what profile you want, like per specific customer or just for all of them. And here you go, that's the current coverage provided by Sigma project. So that's the that's handy for, again, mostly for gap analysis, but not for like coverage analysis. So that's how it looks like. Next thing, we are not limited to Confluence. At the same time, we generate absolutely the same information we have in Confluence in Markdown format, so you can use, if you don't like Confluence, don't want to pay money, or I don't know, any other reasons, you can use Markdown renders engines like GitLab, GitHub, or any others you prefer, and you will have absolutely the same information there. Each time executing make, we have all the entire knowledge base in Markdown in one of the folders in the repository. Next thing is analytics.csv. So basically, if you don't like Kibana, if you don't have Kibana for some reason, you can just use analytics.csv. It has absolutely the same data. You can answer absolutely the same questions using filtering, or maybe if you're a fan of Bash, like cut, pipes, and everything, use this stuff. So here is the example of filtering for pass the hash, and you can see what data needed you need for that. Also, there is a mapping to triggers. Again, logging policy, like always, data needed always came with logging policies, and everything else. Next one, which is also quite important, called pivoting.csv. This file destined to provide you with information where you can get some specific data type, like hash, for example. What kind of data source can provide you with this information? Like you need hash, for example. So you put there a hash, and it shows you the list of data needed or log sources where you can find this hash, which is quite handy for triage and initial response, and basically, you know, for understanding. So as you remember, we created another entity called dashboards with simple lists to links, to other visualizations, and we automatically converted to JSON file for Kibana. Also, you can automatically or manually upload this JSON, and you will have this kind of dashboard. We also have it in our demonstration version. It's available using the same link or QR code, and we built this dashboard with MITRE project data. Tomorrow, Roberto will present this project and tell you more about it, but just it's worth to mention that there is something to see, to just check how it works and why it is important, handy, useful, and everything else. All right, let me summarize this stuff. First of all, we had a few expected pros, which are working with text files, not working with web, which is main goal. So basically, we now use our favorite IDE or do bulk changes using Bash or Python or anything we want. Use Git flow, CI, and everything to, you know, just for general programming or development. Use the merge requests, push requests, and everything, and to check new contributions for other team members or from other even teams. Like if CM guys want to add some information, no problems, use Git flow. We will review your stuff and merge it if it's okay, or provide you with information what you're supposed to change, which is quite handy. So basically it's some sort of analytics as a code. Total automation. We don't do almost like anything manually, nothing manually. We don't do mapping inside Confluence. We don't support these triggers in the Confluence. We don't support detection logic in the Confluence. Basically everything generated by itself. And everybody has all the time the actual information, so which is like just great. For now, we work only on meaningful data, doing research, doing development, and the rest is automated. So that's just fine. At the same time, our data is compatible with community projects like Sigma and Atomic Red Team. So basically, we can just do git pull data from their project, and automatically natively integrate it to our environment, which is also just great. I have to speed up, I see. There are a few unexpected pros. First of all, visualizations of existing analytics. As I said, we started with generating of analytics CSV files, but then we realized that why don't we generate Elasticsearch index and analyze all this stuff inside Kibana? And we just did, and we saw what was the result. So for now, CM team has their own dashboard to track implementation, like they see how many detection rules they can implement, and there is a list what kind of logging policies that data needed they should collect and everything. At the same time, our leadership has their own dashboard where they see how we're progressing, like how many detection rules we implemented, how they were changing with time, and everything like that. At the same time, it's all automated automatically. Sorry, automated automatically, such a horrible thing. Updated automatically. Just, we updated something, like new detection rules, added something, or updated customer entity, executed make, and all the information were pushed to all, like Kibana, Attack Navigator, everywhere, basically everywhere. So each time somebody opening this dashboard, everything is brand new, updated, and actual. All right, I will skip this part, last point, and just jump into goals and plans. First of all, we want to stimulate of Atomic Red Team and Sigma projects format use. It is obvious because more contributors they have, more interesting and valuable analysis we can do and provide back to community. At the same time, we will have more interesting ideas, analytics, execution frameworks and converters, which is also great. Another thing is evangelization of MITRE ATT&CK. I believe we as a community need more projects with MITRE ATT&CK taggings. And first example of such project is Metasploit. Just imagine what will happen if we will tag all the post-exploitation modules of Metasploit. There are basically more than 300 of them. We will dramatically increase our simulation testing ability. Another thing is that there is no project for automated hardening with mapping to MITRE ATT&CK. There are lots of projects which do hardening using Ansible or other configuration management systems, but none of them use MITRE ATT&CK tags, so we cannot implement it. So if you guys were seeking for a project to do like next couple of months or maybe years, it's a good one. So you can find us, we can discuss it, maybe provide you with some help or advices, anything. You're welcome with that. And last but not least, this week in Brussels on EU MITRE ATT&CK workshop, we're going to present our definition of coverage / completeness of coverage for a technique, MITRE ATT&CK technique. We will discuss it with community. And based on final, let's say, decision, we probably will initiate a few coordinated sprints working on some specific gaps we will identify together with the experts from the community. All right, thank you for your attention. If you guys have any questions, we would love to answer them, but I see that time is just running out.
Thanks, Daniel. Thanks, Mateusz. Yeah, we have a few minutes for the questions. So if you have any question, please raise your hand, and we will provide you a microphone. Yeah, up there.
So I know you mentioned using the Hive for your response framework. Do you know if anyone's been experimenting with using this with any of the other security automation platforms, Demisto, Phantom, etc.? Because it seems, I'm really curious about how well we could get this in use by the commercial products as well.
Mm-hmm. We had a conversation in on first TC in Amsterdam last month with guys from Palo Alto. They just acquired Demista, and one of them was exactly from Demista. And they told me that they were also trying to implement like new Playbook format, but they were using JSON. And there is idea to invent, or I don't know, propose common format for playbooks, which would be like human and machine readable. We believe YAML is the best for that, and our format is kind of okay-ish. So there is an ongoing conversation about the common format for instant response platforms, and maybe in the near future we will have something like common format which will be supported by most of at least instant response platforms. And I cannot say anything more about other like EDRs or anything like this. No information about it.
Yeah. Guys, you've solved, I'm here, thank you. Guys, you've solved a lot of my questions that I had when I was working in a SOC. It's really impressive. How do you handle, I'd say, customers that have their own opinions how incidents should have been handled? I mean, are there like customizations for a given customer, or do you kind of, or is this format convincing enough for them to actually do it the right way?
Well, basically, it is a quite interesting question. Thank you. For us, like as a project which use like Git flow and anything, it's not a problem to create like fork per customer, and basically that's how it works. So we don't like share information between customers, and if they have some specific requirements, it's not a problem to implement like response action specifically for the customer, for customer environment, and map them to Playbook. So it's just very flexible. No problems with that.